So that, yeah. Hi
Well,
there.
welcome everyone to the Cannabis Data Science meetup group. This is a group where we meet at least once a week to talk about cannabis data and how we can apply data analytics. Here's a guest, Heather, who joins us regularly. And so, my name's Keegan. I founded a company, Cannalytics, and we're here to make cannabis testing simple and easy. And while doing so, we can provide rich analytics to everyone in the industry. So that's my comparative advantage. So I'm always just here to share. And I'll let Charles, would you mind introducing yourself real quick?
Hi, I'm Charles. I have 27 years of software engineering experience, and I've been transitioning into the data science area. I have experience with TensorFlow and machine learning, genetic algorithms, and this has been a great group to get some practice and work with some interesting data.
Definitely. And then if they want to, if you want to go, I'll go around. If you want to share a bit about yourself, feel free to jump in. So I guess next is Alan. If you're interested, would you like to introduce yourself?
Yeah, hi. So I'm Alan, and I'm transitioning into the field of data science from being a science educator for 15 years, and graduated from the Galvanized Data Science Bootcamp, and yeah, working on improving my skills and trying to get a job.
Excellent. We have a pretty regular guest who is on vacation this week or will be back next week. Paul, and he's also getting a degree in data science. And so what we found is the cannabis data is some of the richest, interesting data sets out there because, especially with the traceability systems, you have such granular high frequency data. So it's fun to do analysis on regardless of your background. Matt, if you're interested, would you want to introduce yourself real quick?
Hi, everyone. I'm Matt, and I work with an ERP system called Plex, and I write SQL reports using IntelliPlex and SQL development. So I'm really good at SQL, and I'm interested in this group to access the APIs to write RESTful services to access the RESTful data and to manipulate it like in Tableau or something else. That's it. Thank you.
Awesome. You're in the right place. So we touched on APIs. So I put up a couple of videos on YouTube where we go through some API work, but Cannalytics has put together an API primarily for labs to use, but anyone can use it to store and access their lab results. And then Cannalytics also has a module to interface with metric and leaf data systems, both of which have an API that serves the traceability systems in their respective states. So you're in the right place.
Okay,
Kelly.
good to hear. Thank you.
Awesome. Kelly, were you interested in introducing yourself real quick?
Yeah, I don't think I'm in the right place, actually. I'm
Maybe not.
Kelly. I'm Kelly, and I'm using CBD right now. So I was curious. But you guys probably are going to roll right over my head.
Well, you may want to stick around and listen because one of the things I put together today is, so first we may look at some work Charles has done, just predicting when like a sample would fail quality assurance testing. So that affects you. That's when products make it to the shelf. And then the second thing is we're going to be looking at hemp testing data. So people who are growing hemp, they need to get it tested to make sure that it doesn't have high levels of THC, then it predominantly has CBD. So they need to get that tested before it makes it to the shelf for you. So we're sort of doing analysis upstream from from your products to make sure that what you get is what it says it is on the label. So that's the idea.
Yeah. Okay.
And then, Heather, are you interested in introducing yourself, or?
Yeah, sure. I'm Heather. I've been joining Cannabis Data Science for a couple of weeks now. I'm going to confess to you that I don't have data to share and no code to share. I am currently looking for a job. My goal is at some point soon to be working in a cannabis lab testing something. I'm trying very hard to bring my QC experience to light in the cannabis industry. So anyway, I'm observing a lot, and I have a lot of questions, but I'll reserve those till after the presentations. So thanks.
Oh, awesome, Heather. I may have to forward you some job openings because there's lots of laboratories that are looking for people right now. So
Thank
so
you.
you're in the right place, and yeah, you're welcome to learn from us. Use data and use any snippets of code that you may find useful.
I question data too, so you're talking about the quality assurance and the levels of anything that's tested. I'm finding that at least with some of the products, so I live in Maryland, by the way, so some of the products that I've been using over the last year, their tests, the terpene levels have changed, yet it's hitting the same. So, and there's a lot of discussion on Reddit, people complaining about the terp levels not reaching above 3%. That's a very local issue. But so anyway, testing is an issue for somebody that makes homemade oils and everything. We're interested in what we're putting out to ourselves, our local market, if you want to think about it that way. So numbers do interest me, and why they change without an apparent physical change is something of concern. So I like to question data when I can, but that's not just for for entertainment value. It's for the sake of the product, the quality, and what we're using it for. So, therapy, pain management, anything that you need, we do want to know what's in it and why. So, thank you. I'll shut up
Well,
now.
you've got an inquisitive mind, so you're in the right place.
Thank you. I feel welcome. Thank you.
Awesome. And welcome, David. Real quick, we were just doing a round of introductions. You would actually happen to be the last. If you're interested, would you mind introducing yourself real quick, or we can kick it off? Either way.
Yeah, no problem. Sorry, I'm actually at the gym, but I wanted to definitely not miss this. Yeah, so I recently got into data science. I have a background in mainly business, project management, and also have a project upcoming that I want to do, a capstone project on just specific finding different data sets and then showing the skills that we've kind of recently went over, which is Python, Tableau, SQL. And so this is very appealing to me. So I wanted to hear a little bit more about it. I've also been interested in part-time investing on the stock market. So I figured it would be a great way to just get a little bit more of a solid foundation, get enough, just become more educated in this space.
Awesome. Well, welcome, David. And so, welcome, everybody. And so, let's just go ahead and kick it off. And so, for starters, I think I can present, unless you want to present Charles, but I think if you're open, we can start showing some of the work that Charles has done, predicting the probability that a sample will fail quality assurance testing. So when the sample is sent in, depending on its attributes, what's the chance that it's going to fail? So can you start to predict that ahead of time, essentially? Do you want to present, Charles, or should I?
You can present.
Okay, awesome. Okay.
Okay, so I looked at how could you tell using the Washington data if a sample would fail, and so in order to do this, you have to you have data that's from the past, like the type and the date it was test, or the type and the lab ID and the producer ID, and right, and you also have data from the future from after it was tested. So you can't use any of that because you can't peek into the future to make a prediction. Um, so so I just read in those things and and tried to use those. So yeah, I mean, there's a lot of data there from the future, but so yeah, so I read that stuff in, and then you can just keep scrolling down to let's see, yeah, and I went through and I kind of checked and got rid of data that was missing data or tried to fill in data. And so the one thing that you have in that data is the product type, which you know ahead of time. And I looked at each of the product types, and there's actually less than 1% failure for each one. I mean, they're really, really small values. So this is going to be kind of, so kind of difficult to find. And then also, there's also it's around a 1% failure rate. So you have a lot of passing values, but not a lot of failures.
Yes.
So, yeah. So, so that makes it difficult. And I went through. So there's a type and there's an intermediate type, and I tried to go through the intermediate types to see if that would be useful. So.
Sorry.
But there was a lot of missing values, and it was very, there wasn't a straightforward way to fill in the values. And for some of the types, there was only one value, so they would just be, 1-to-1 correlation, and it wouldn't really add any information. So I ended up dropping the intermediate types.
Yes. And so it looks like the ones you want to focus on here are like I think the flower lots are what's getting tested. The flower may actually just be like wet flower that may be getting transferred for processing. I need to double check on that. And then of course you'll want the breakdown of the concentrates. So, but some of the, it may not be worthwhile looking at some things like capsules and whatnot, but it depends on the data. But it seems our biggest challenge here is just the prevalence of zeros, right? So the prevalence of samples that pass make it hard to predict the black swan. Yeah.
And these numbers are percentages, so they're really, really small. Or no, I guess it's normalized, but yeah. So, but I mean,
are these failure rates right here, or
those are the number of samples that there are among the total samples.
Yes. So is this saying there's 50% of the samples are flower lots?
Yeah. But 84% of the rows had no information. There was no intermediate type listed. So it was kind of, how do you fill that in? And I couldn't come up with a good way to fill in that missing data.
Okay, that's a large percentage. So did those have lab results, that 84%?
Yes.
Did they have a product type? So they were just all end products, I'm thinking, or?
Yeah, there was a product type there, but there was no intermediate type.
Well, it's a chance they just weren't end products, but it could be just bad. It could be, missing data. So
Right. And there was just no way to figure out, you know, a good way to fill it in without just, without sort of corrupting it more. So I just didn't use the intermediate type. I think the intermediate type would have really been helpful. But it just, there was, there wasn't a clear path forward on how to fill in that missing data.
so instead, did you go with?
So I just used the product type because that I had, though that was all, there was a product type for filled in for almost all the rows. And so I didn't have to drop that much data for that. Right. And so for like marijuana, there was flower was the only intermediate type. So if you had marijuana and flower, right, the flower didn't add any more information to the marijuana, right? It was just 1-to-1. So it was just extra. It was just going to be an extra feature to use, and it just would have made it more complicated for the learner because it had this extra feature, but the feature didn't add anything.
Yes. So I think we may just need to narrow our analysis down, and that may be what we get to today with the hemp analysis is. So it may be worthwhile to just look at the failure rate for flower, right? Because, well, the other ones matter as well. But, ultimately, right, you need the clean flower, before you process it. Of course, I think you can, just keep distilling out the contaminants. However, we just may need to narrow our analysis just to get some meaningful conclusions, I think. But keep walking me through this. So
okay,
what did you do?
So when you do a classifier, you start out with a dummy classifier, and the dummy classifier doesn't care about what the inputs are; it just outputs something. So I came up with a dummy classifier, and then because there are only a limited number of product types, I one-hot encoded them. So because you have to use a numeric value. You can't use the text value. So what that does is it takes the value and it adds a column for each type, and then puts either a 0 or a 1 in that column depending on if it's that type. So you can see like the first one, it's harvest material, so there's a 1, and all the other values are 0. And so it's the next one's intermediate type, and so this is a way for the classifier to be able to use this categorical data. So and then I label encoded the status, because again the status was pass and fail, but it actually has to be either 0. It has to be 0 and 1 in order for the classifier to understand it. So, and then you split the data into a training set and a testing set. So I held out 20% of the data for testing. And then I trained a dummy classifier that output the most frequent value, which is pass. So it just, no matter what you give it, it outputs pass. So then when you look at it, you have to figure out like what is a good metric to use to judge your classifier, if your classifier is good or not. So if you look at the recall, it's 99.25%. I mean that looks like it's a great classifier, but it in the confusion matrix down here, you can see it got all the passes right, but it got all the failures wrong. So that's not really good. So some of this macro recall and balanced accuracy are at 50%, which is kind of really what it is, right? It got 50% of what you're trying to determine correct.
So basically, the training data is almost all passes, and so it basically the algorithm just predicts pass every time, essentially.
Well, that's what it's supposed to do, right? If you have this is a baseline. Like, so you should be able to train a classifier that outperforms the dummy classifier, right? The dummy classifier it only outputs pass, or this particular version of it. And so this is just to see if if your classifier is actually the real classifier actually works. And so I did a second dummy classifier that output a distribution is stratified based on it does a percentage based on what the actual training data what it outputs. So it didn't really do much better. Right, it comes up with a 98% recall. You scroll just a little bit, but it still does really poorly on the failure.
And so, is there sort of a problem where it's going to start predict? Well, and then this is actually one of the things that you need to keep in mind. So one of the rules of forecasting is know the forecasting error. So what's the bigger problem? Is predicting a pass when it's actually a fail, or predicting a fail when it's actually a pass? So what's the the cost of being wrong? So
right, but again, this is a baseline. This is what we're trying to outperform. But yeah, so, and again, it's about 50% right. So because this is an imbalanced data set, you can calculate these weights to help influence the output, and so it'll sort of weight the failures, the weight, or it'll boost the weights that predict the failures above the ones that predict passing. So I calculated those, and then I used a logistic regressor to come up with it, or to do an analysis again, and only using the type, the product type. And you can see that it actually does much better, at least at predicting failures. It gets 96% of them right, but then the passing ones drop down to 76%, and you get 24% of values that should have passed predicted as failures.
Okay, so with this model, it's only getting hold on, walk me through this real quick. So it's getting 75% of the it's calling a pass correctly 75%. So that's a true pass.
Yes, and it's getting 96% of the failures correct.
Wow. So those it's accurate. So that's saying a fail when it is a true fail.
Right, and sort of this balanced accuracy, right? It's about 86%. So, right, because that takes the average of the of the pass and the failures, the correct passes and correct failures, and and that's about where it should be. If you take those two values and add them and divide by 2, it's about 86% correct. So,
and then what's the percentage here where it's labeling it a pass when it should when it's actually a fail?
That's that sort of purplish, dark purplish.
Okay, yeah, that's what I thought.
Yeah.
And so is that 4% or?
Yeah.
Okay, so So that's the square you're really worried about, where the algorithm predicts a pass when it's actually a fail. Because, if the algorithm predicts a fail and it actually passes, it's not basically. So the idea is you want to, test the failures like as quick as possible. That way you can do all your quality assurance tests to make, that the laboratory does to make sure that it is in fact a fail. So predicting that it's going to be a fail and it's actually a pass may kind of increase their costs a little bit, but what you really want to avoid is, saying it's a pass when it's actually a fail. So to me, this looks like an outstanding fit. Is this way it looks like to you?
It
Or
does on the surface, and if you as you go down, I'm actually able to improve on this. So I took in the lab and the producer and added those as features.
interesting.
Because again, those are things that you know ahead of time. Right? There aren't a lot of things that you know ahead of time. So then I used the cat boost classifier, which is a better quality classifier. And I did that only on, I used only product type.
Okay, so can I ask, what are all the factors we're using in prediction at this moment? So are we just using these 3 variables to predict failure rate?
Up to this point, we've only been using the product type, which I find really weird that like somehow is that accurate. But
Because it seems like it would just be kind of
it seems like it would be random.
Yeah. Well, so once we'll have to test it in practice, I think. So what happens when you take into consideration lab plus producer?
Okay. So first I used the cat boost classifier with just a product type so we could compare it to the previous classifier. So if you scroll down some more, let's see. So yeah, it's slightly, it's actually about the same. It's very close to the same. I think it gets more of the passes correct. And then when I use the lab type in the producer, or the lab and the product type, the lab and the producer, I got this. I got 99% of the failures correct, 79% of the passing correct. It's down to what, 0.005 for incorrectly predicting a failure, or predicting a failure as a pass. So this seems really good, but if you scroll down a little bit, this is these are the actual numbers. So it gets almost all the failures correct. It only predicts 17 failures as passing, but it predicts 83,550 passing values as failing, which is huge.
So,
sorry, I just had a question to help orient myself. And the total amount of failures is the 2,951 and the 17, right? Like those are the actual true failures?
Yes.
Okay, cool. Thank you.
So I guess the amount of, what do you call it? I guess false positives. I guess that would be, depending on if you want to call it failure or positive. So yeah, I think in this case we are. So I guess if you put all of those ones that you predict as failure, but they're actually passes on the assembly line, it may still. I think it would still increase efficiencies, but you're right. It would still kind of. Basically, the lower you can decrease that, the more efficient you are, and then of course, the lower you have this number in this third quadrant, sort of the safer you are. So that's the way I look at it. So if you lower this number, you're going to be safer, and then if you lower this number, you're going to be more efficient. And of course, you want to maximize these two quadrants. When you're predicting fail, predicting pass. So.
Right. I mean, there's a limited amount of information there, and it seems really odd to me that those combination of features, is able to predict this accurately. But that's what it seems to be doing. Now, what it's actually doing underneath, I don't know. So, the really interesting thing about this was that you can ask the model what features were the most important in making its decision, and product type is like about 24%. The lab ID was 74%, and the producer was like 2%. So,
well, I think that may be a problem. So because the lab ID would tell it if it fails. So I think you need to exclude the lab ID from the analysis, right? Because that's why it's almost like perfect, because it's just certain lab IDs just should always fail, right? Or
no, the laboratory doing the testing.
Like the I see what you're saying. Like the laboratory license ID. Yeah. I see what you're saying.
So, I mean, and this sort of brings up the point, do certain labs fail? Are they more stringent in their methodologies and they fail more product, or do they just tend to get product, from, that fails more often? I mean, it's kind of, and it's interesting that it's actually not, it's not really closely correlated to the producer. So I don't know. This brings up a lot of questions, and this is kind of as good as I could get. I actually ran the last classifier through Optuna, which is like a genetic algorithm, and it goes through and it keeps running tests. It keeps trying the classifier with different parameters to optimize it. It ran for like about 12 hours, and then I got that tiny little bit of improvement.
So I think this is fantastic. And so I'm curious. It makes me curious because it seems to me like an exceptional fit with very limited predicting factors. So we could you could potentially try to cut your teeth on with these same models is, so just if you're okay with slightly changing gears, but we're actually going to keep this whole analysis in mind here for a second, because basically what I wanted to show you is there's this hemp database. So still cannabis, however, hemp, they're actually shooting for low THC levels. And so there's an interesting database here put out by the University of Illinois, where they basically have cultivators submit some information about the strains they're growing. So essentially, how they planted it, when they harvested it, And then they are getting it tested at several of these laboratories, ACT laboratories, Pride, Rock River, and perhaps a couple more here. And so we actually have nice data on so here we have just essentially the strain, the cultivar. The source, I'm not 100% certain if this is the producer or perhaps the seed company. I've got a feeling it's the producer. You also have the state, so this is for the Midwest. So you primarily have Illinois, Wisconsin, Indiana, and Michigan, I believe. And so then you also have the county. And then what I think is going to be an interesting predicting factor is the sample date. So here they're measuring total THC and total CBD. Well, they're doing CBG and CBD, it looks like. So hemp producers, they want a high level of CBD, right? Like this 13% CBD that's outstanding. And so that's what hemp producers are trying to produce, right? Because for example, Kelly, they need to process this into hemp for people to buy on the shelves. So the higher percentage the plant is, the more efficient your extraction is going to be. However, watch out, because look, the average, this actually has a 0.4% THC. And so they would actually have to destroy this lot of hemp. So even though that lot of hemp has 13% CBD, it breaks the federal limit for hemp, which is 0.3%. And so that would actually be a failure rate for hemp. And so what you see is the failure rate for hemp, that's going to be a lot higher than the failure rate we observed with quality assurance of recreational cannabis in Washington. So, Charles, I was thinking your model may be useful for using some of these factors, such as cultivar, source. I was going to perhaps look at state today with you to see if what state the cannabis is produced in may have an effect on its failure rate. And basically we want to see, okay, what's the chance of the cannabis, the hemp, being less than 0.3%. So just to go ahead and show you this data, I've gone ahead and scraped it into just an Excel sheet. You're welcome to as well. Basically, I just copied and pasted this 100 observations at a time. If you think of a better way to extract this data, then definitely let me know. But just sort of brute force collected it. And so this will actually be the first time that I'll have done analysis on this. So we can actually do it live, and essentially we may need to conclude next week. But basically the idea is we want to first calculate if the sample passed or failed based on the total THC levels. And then we essentially want to try to predict, say, the failure rate given some of the factors. So for today, I was going to start looking at state. So we're just going to do this live real quick. So well, I suppose I can run it here in VS Code. And so first things first, let's just read in the data and just start doing a little exploration here with some of the time we have. But any thoughts so far, Charles, if this is data that you may be able to work with?
Yeah, actually, there's actually more features that are known in advance with this. So this, I can definitely try this.
Okay, so it looks like we have our so I may move over to Spider here in a second, but we'll start with VS Code. Okay, so we've got our variables. Well, actually here, first we actually want to read in the correct sheet. Okay, so I went ahead and collected several of the, well, collected all of the data points here really. And so you may want to take a look at this, Charles, and everyone else as well, but I didn't see if there was quite a one-to-one relationship here. So basically, you see there's 253 what they call cultivar entries. And so this says the harvest date. And, you see, for example, there's 3 abbeys. And then when you go and look at like the summary table, you see there were 3 abbeys, and then this just has their average. So this is trying to uncover like, okay, do specific strains have sort of expected CBD and THC levels? So essentially, hemp producers are trying to sort of narrow it down and sort of settle on some stock strains that they can rely on, because as you can see, people are having a problem with failing for THC levels. Here is the more granular data. You can see the 3 abbeys and you can see the 3 different tests. However, there's 753 test data points. So I'm not certain how these map to the cultivar entries. I've got a suspicion that perhaps, say, a farmer planted a field of berry blossoms, or what's common strain you see is this cherry wine, cherry blossom. So if a farmer grew a field of that, they may sample it multiple times. So we still need to get to the bottom of this data, and because it would be nice to be able to combine the cannabinoid data with the harvest date. Second, the next best thing to the harvest date we have is just the sample date. And basically to show you some of the figures that they've put together that we'll be recreating is essentially, here is a plot of total THC to total CBD. So as we mentioned earlier, right, the producers, they want to maximize their CBD while staying below the federal 0.3% threshold. And so what I noticed that's interesting, and I actually just noticed this looking at this time is it looks like there's a slight positive correlation here. So, and that would make sense. Generally, the plants that are producing higher cannabinoids, higher CBD, also produce higher THC. And so you're sort of playing a dance here where you're trying to grow the highest CBD plant you can to the point where you stay below the threshold. Because as you can see, I mean, it's looking like a non-negligible portion of the sample is failing.
So one thing I've read is that, and the data here to do this analysis is here. The time between the harvest and the testing, apparently after you harvest hemp, the THC level increases, and after a certain, like, people have tested their hemp and it's passed, and then they're like transporting it and they get pulled over and they test it and they fail because an amount of time has passed where the THC level has risen. So there's sort of this race against the clock.
And you know what's happening is it's these CBG levels. So THC is I'm not going to use the correct scientific word here. It's a derivative of CBG. So CBG is a precursor element. So or maybe CBGA. I may be getting it wrong, but essentially all of the cannabinoids essentially have a common precursor, and depending on various factors, such as you mentioned, how it's stored, determines how the chemicals, break down and oxidize into different, or how they break down and turn into different cannabinoids. So that's an interesting observation, Charles. So we may not be able to incorporate the CBG levels, but what we could potentially even try to do is say you're, I don't know how we would work this into our analysis, but say we could try to predict. So say you grew an Abacus strain. Okay, well, given that you've grown an Abacus strain in Wisconsin and that the, historic Abacus has a, is expected CBG level of 0.24, given its, historic averages, you could almost try to predict, the probability of, a sample failing. So I think this would be incredibly helpful analytics to hemp producers, because essentially if you could give them like a chart, because what I think would be cool would be to plot a figure. So like you were saying, so on the x-axis, you would have number of days. So you could have like number of days between harvest and sample date. So it would be interesting to see if the number of days in between there would affect the probability of you failing for high THC. So that's the analysis we're going to start doing. So like I said, I'm just now starting, so you're going to see me basically just start hacking at this live right now. But then I think we can continue this next week and actually build a good model here and actually make some worthwhile predictions and produce some good statistics here. So first, let's just, like I said, rule number one, look at the data, So let's see if we can't do just that. Okay, so we've got 752 samples here. The average is 5% CBD. You've got the average THC is 0.23, so about 0.24%, which is just squeaking under the cutoff. But as you see, there's a standard deviation of 0.2, 0.2. So you're going to have a large amount failing. And so instead of just saying a large amount, let's actually calculate that real quick. So let's just say, okay, why don't we just calculate the length of the data where and I may rename these columns here in a second for ease of use. So we want to locate these where the THC is greater than or equal to 0.3%. And it looks like we've got a column naming issue going on here. Okay, so for ease of use, let's just rename some of these columns real quick. And I'm just going to do it here just so thanks for bearing with me. So now it's just going to be a bit easier to work with the data. So now we can do this a bit quicker. So let's find out all of the data. Where it's okay, so we've got 184. And so what's the percentage? Well, that's just going to be out of the total data set. So Charles, this may give you a bit better of a failure rate for your models, because here we've got, almost 25% of the samples failing for high THC. And that actually sounds about right from my historic experience. And so it's actually a major concern for hemp producers, because historically, I don't think every hemp producer was getting their product tested for THC, but it's because you now have to get your lots tested. And so, cultivators are, it's a major bummer, right? Because you've gone through your whole harvest, you've done all of your work, you've harvested, you've dried, you've cured, and you send it in, and you fail for high THC, and the rules say you now have to destroy your product. So that could be a devastating hit to farmers, to cultivators who aren't expecting that. So that's why it's important to look at this data, so that way farmers can know ahead of time, depending on what strain they're growing, or when they're harvesting, what's their probability of failing? Because as we've noted, they're playing this careful dance here where they have to wait as long as they can to kind of get their CBD levels up. But then, you need to harvest before your THC becomes a problem. Okay, so now we essentially just want to code here if it's a pass or a fail. So we'll just say fail. So how can we assign 0 or 1 here? Do you may know off the top of your head, Charles?
You can use, is it the label encoder? Scikit-learn's label encoder. It'll, or you could do just like you could do a map. You could do like a pandas map.
Hold on, I think this may. So I think this may do the trick here, but you're seeing essentially how about this. But basically, we just want this as a 0 or 1, where it's a 1 for failure. And so we want this to be a failure wherever it's greater than or equal to 0.3%. And there we have it. Okay. Okay, so we're running near the end here. So essentially what I'm going to do next is essentially run a logistic regression of the failure rate, because this is 0 or 1. Yes, and so this is where you can do some real interesting analysis with some binary models. And so we're going to use the logistics regression. So basically, like I said, we may need to wait till next week, so that way I can actually write the model and have it ready to go for us. But essentially, I'll be using the logit, and then so that's our dependent variable, and our independent variables we'll want to think about how we can work with these. And so right off the bat, I was thinking, okay, we can basically use dummy variables depending on what state they're in. So real quick in the last minute, we'll talk about some of the factors that we'll use for next week's analysis. But basically, I'll be using state to start with. Right. So we essentially have Illinois. We'll have to keep into consideration that it looks like it's spelled in 2 different ways here, or it's got a space. So we'll want to make sure to strip out that space. But we basically have Illinois, Wisconsin, Indiana, and Michigan. And so right off the bat, I essentially want to, calculate the failure rates in these states, right? So for example, so for example, Data. So you can start to, right off the bat, just look at conditional averages. So if you've been here before, you'll know that I'll say that you can find extraordinary insights by just taking conditional averages. So we'll start doing formal regressions next week. So next week I'll show you a logistic regression where we start to predict failure rates. But for now, I'll let you start looking over this data. I've published this to GitHub. So you should be able to find this data set here on GitHub in the Cannabis Data Science repository. So I'll let you start looking at this data yourself as good Bayesians until next week. And then that way you can establish your priors, and then we can do our analysis next week. And like I said, start looking at some conditional averages. So for example, just this simple one, right? You've got a 4% higher failure rate in Indiana than in Michigan. Interesting. Maybe that's insignificant. Maybe that's significant. So next week, we'll start looking at some of the factors such as state, and potentially try to use harvest date and sample date. We'll have to be creative on how we measure that. So maybe we measure how many days into the year it took them to harvest. So everybody think about that. And we've reached the end of the hour here, so I'll let people get on with their day. But are there any questions, comments, concerns here at the end? Did you learn something, David? Was it worthwhile?
Yeah, absolutely. It's a shame I'm not in front of my computer because I would like to try to duplicate some of the stuff, but yeah, absolutely. It's quite fascinating. I would like to find out, this is just on my own, grab some of that data and compare it as far as soil, what's in the soil within each individual state or each individual area where it's cultivated.
I like how you think, because that's exactly how you get these brilliant insights. You take one data set and you combine it with another. And so you had a brilliant idea. Look at the soil. So if you can get soil data based on Michigan, based on in Indiana, Wisconsin, Illinois, perhaps there's a factor in the soil that's affecting failure rates in the different states. So that's exactly how you make these brilliant insights, is combining data sets. So I like how you think.
Thank you.
Awesome guys and gal, Heather, so crew. So it was awesome meeting with you all and talking about cannabis data. And we've got a good amount to dive into next week. So next week, I'll have the logistic regression prepared. Charles, if you want to apply your prediction model to the hemp data, I think we've got some good insights we can uncover. So
Thank you very much.
definitely. Well, it was awesome speaking with you all today. And until next week, have a productive week.
Thanks. Bye. Bye.
Take it easy. Thanks a lot.
Have an awesome day.
You too. Bye.
Bye.